we are having a question by using properties of determinant show that. Now the question has been little bit changed, we have to show it, we have to prove it. So always go for a motto that in a question you are going to make at least in a row or in a column 1 1 1. Okay, if we are having 1 1 1, it means 90% of the question has been solved. Okay, here it is already 1 1 1, so let's start it. Now left hand side. Now in the left hand side, what type of operations when we are having 1 1 1, if it is in column then apply for row, if it is in row then apply for a column. Okay, now what properties I am going to use here? I am going to use here R2 approaches to R2 minus R1 and R3 approaches to R3 minus R1. Okay, now when you are using two properties in a same operations, then it will be considered as you have used two separate properties. Okay, so now what I have done it here, now we have got it 1 a and a square, row 1 has not been changed. Okay, for row 2 1 minus 1, now R2 minus R1, 1 minus 1, 1 minus 1 0, then b minus a, then b square minus a square. Similarly 0, c minus a, c square minus a square. Okay, so this property I have used twice, two operations in a single step. Okay, now after this we are getting, now what we can write it here, we can write it 1 a square. Now what I am doing, I am just putting an identity here. Okay, 0 b minus a, b minus a, b plus a, then 0 c minus a, c minus a, c plus a. Okay, what I have done, I have used the identity, and identity is a square minus b square is equal to a minus b into a plus b. Now what we are having here, it seems that we are having b minus a here also, b minus a here also, c minus a here also, c minus a here also. Now I can take common b minus a from R2, I can take common c minus a from R3. Don't think here it is 0, then what we are going to do it, because if here it is 0, then think it that we are having only 2 by 2 determinant. Okay, because if I am taking b minus a common, now if I am multiplying b minus a with 0, it will be 0 only. Okay, so we can take common from R2 and R3. Okay, now writing here, taking b minus a and c minus a common from R2 and R3. We have taken common b minus a and c minus a from R2 and R3. Now what we are getting? Now we got it, for this part we got it b minus a, then c minus a. Now what is left? It is 1 0 0, a 1 1 and a square, b plus a and c plus a. Okay, now when we are getting two zeros in either of the row or column, then expand the question. Need not to apply again any type of operation, because if you are trying to apply one more operation or two more operations, one more operation you can do it. You can take it that I am going to apply for C3 minus C2. I have to make 1 0 more. It's okay, no problem. But sometimes in the difficult questions, if you are applying 4 or 5 operations, again you are going towards the question, not you are solving the question. Okay, so now b minus a, c minus a. Now expanding, we are getting here it is b minus a, c minus a. Now b minus a, c minus a with, now I am explaining this part, 1 with, now 1 into c plus a, it is c plus a minus 1 into b plus a, C plus A minus B plus A. Okay, and rest part will be 0. Now A minus A with we are having 0 plus A square again with 0. Now why it is 0? Because when you are taking minus A, 0 with this and 0 with this, both 0. Then A square 0 with 1 and 0 with 1 again is 0. So need not to go for the further two steps, because when we are getting two zeros here, only first part will be solved. Okay. So now this becomes B minus A, C minus A, and now C plus A minus B minus A. So we are having B minus A, C minus A, and here it becomes C minus B. Okay. So now what we want A minus B, we are having B minus A. We want B minus C, we are having C minus B. We want C minus A, C minus A is there. Okay. So now I have taken minus 1 and minus 1 common, and what we are getting, just look at A minus B, B minus C and C minus A, and finally this becomes minus with minus, negative with negative is positive. Okay, so it is A minus B, B minus C and C minus A, and this is what? This is right hand side. Okay, hence we have proved. Okay, the question has been proved. So similarly you can go for the steps, and after applying 2 operations or 3 operations, need not to go for the 4th operation. If you think it is little bit more easy, simplification can be easy, then you can go, otherwise you directly expand it. Okay, and applying for 3 operations in examination, suppose the question is for 4 marks, you are applying for 3 operations and you couldn't solve the question, still 60% marks will be awarded to you, 2.5 marks will be awarded to you.